So, good evening to everyone. Welcome to day 4 for this bootcamp as data analysis using Python. Okay, so far we have seen some component of Python. So, till now we have a small idea, a rough idea what exactly is a Python. What is a programming language? Because if you want to do something in the field of technical, right, or in the field of technologies, and there are subdomains of technologies, you should at least know the language you have to speak in the technology field, right? And one of the language we have encountered with the Python, right? So you might know Java, you might know C++, and that are the languages that you encounter, right? With the help of these languages, you can easily build different products. You can easily build different applications, such as if you want to create a website, you can create that, right? And it has a huge scope in the upcoming time, right? It's not limited that okay, I know I can build a project, I can build an app or a web application, that's it, now everything ends up. No, you can go beyond to your scope. You can start your freelancing, you can make projects for other people as well. Okay, so try to grab some skills using this programming languages. Okay, it has not been sufficient to learn only one programming language, right? So because sometimes what happens is that when you're working on a huge project on a very smaller scale, you can go with one, but when you play around with a huge scale projects, right? So in that case, you should know at least different technologies. Okay, and sometimes what happen is that you are saying, okay, Python is good, Python is very perfect, I want to do something with related to Python. Okay, so that's a very smaller scale, that's a very smaller scale that you're thinking of to create something. Absolutely fine. But when you think into a larger scale, when you're thinking of some project or a product that can make more impact, right? So in that case, you need to add a lot components of different items. It can be an API, it can be an application made up of different languages, and so on and so forth, right? So it's good to know at least a rough idea about different languages, because the concept will remain be the same. Okay, only the thing that changes up is the syntax. Okay, only the thing that changes up is the syntax, otherwise everything will remain be the same, right? Suppose if I speak Hindi and you speak English, okay, in both of the language we can communicate with same manner. In both of the language we can communicate with same manner, but only the thing is, only the differentiation over here is the syntax is different. The Hindi is absolutely different than English, but the meaning will be preserved, right? If I say in English how are you, and if I say in Hindi kaise ho aap, okay, so if you see over here, the syntax is absolutely different, but meaning is exactly same. Are you guys getting this? Are you guys getting the point? Yes or no? Are you guys getting the point? Yes or no? Come on, give me a confirmation please. Okay, so over here if you see, the syntax over here is different, but the meaning is still same, exactly the same way in the programming languages. Okay, so sometimes what happen that people hesitate to learn different languages. They say that because Python gave them a lot of comfort. Okay, that's why it has been known that no, if you want to start with a programming language, no, never try to start with Python at the first glance. It's a advantage as well and it's a disadvantage as well. Okay, both. So if you see in during a schooling time, so it is very rare that a school teaches Python at the first class. Most of the time they choose C++ or Java. Okay, they never jump to Python, because Python is something that gives you comfort, and when something gives you comfort, it makes you lazy. Okay, it makes you lazy and you never want to get out of that comfort zone, right? So now suppose you are enjoying Python. Okay, Python is so good, if you want me to do some project, I can do that. Now if I tell you to do the same project in C, many of you will going to hesitate. You will going to say no. Why should I go with C? C is so difficult as compared to Python. In Python I can do in with just a snap, but in C I cannot do that. With C I cannot do that. I have to first learn C, I have to learn about pointers, I have to see what is the syntax and so on and so forth, right? So try your best. The motive over here is that the first motive is always update yourself with different languages, because languages syntax is different, but the concept will remain be the same. Okay, the variable concept, value concept, the oops concept, inheritance, polymorphism will throughout it will be same. in different languages as well, right? Only the thing that changes up, it's a syntax. This is the first thing, right? Second thing, why it is important, because when you do when you go into an IT field, okay, over there no one will going to ask you that create a calculator. Do you think that if you go on to Infosys, Google or Facebook, they will going to ask you to create a calculator, something kind of project? Do you think that? Do you think that? Obviously not. Right? Obviously not. They will not going to ask you to make a calculator or take if and else game and all that, right? They will going to put you into a project. And what exactly does this project means? You must have heard about project has been classified into various type: minor project, major project, right? So what happened is that project is the combination of technologies, okay? If you say that I have used if and else, okay, I've used if and else and for, and I have made a program for asking a user a question, and according to that I'm replying that. That is also a project, but that will be a minor project because over there you are using a single technology. But nowadays if you look onto any website and application, you will going to find out that all these projects are being used by different they are utilizing different technologies, right? And if you don't know about those technologies, you cannot inbuild those things, right? Because all the technology, it is not promising that all the other technology will be built up on Python only, or they will going to give you relief on Python only, okay? Some of the component they can provide in Python, but if in order to use that, in order to utilize that system in to integrate in your application, you need to have a clear glance of different technologies. So never ever hesitate yourself to come out to your comfort zone, okay? That's a pro tip to all of you. That's a pro tip to all of you, because that's the only disadvantage that I have found out in Python, okay? Python give you so much comfort. For everything you are having a library, for everything you have a community with you that can support you with all of your questions, so you don't have to do much over here. And it's good that you don't need to do much, you don't need to wrangle around, but say at the same time it's bad as well, because it is limitizing your knowledge, okay? It is limitizing your knowledge. You're not growing in that sense, okay? So please, it's a request, kindly no, don't focus on Python only, but instead try to focus on different languages and different frameworks and tools, and how can you integrate that with the help of Python. That's the major thing, okay? So please don't be dependent on Python. That's a pro tip for all of you for today. Okay, so let's come back to the point. Today we are going to start with NumPy. Okay, today we are going to start with NumPy. Why NumPy? What is NumPy? How we can use it? What role does it plays in data analysis? Today we're going to find this out. Okay, so are you guys ready for that? Are you guys ready for that? Give me a yes. Shall we start? Yes or no? Come on. Shall we start? Yes or no? Give me a confirmation, please. Awesome. So let's start with our today's session, and today's session will be on NumPy. Today's session will be on NumPy. Now, if you look very closely to this, look very closely to this, can you see that NumPy is been made up of two words combined together? It's like an acronym of two words, right? It's an acronym of two words. Nowadays, if you see a lot of entrepreneurs do that. They want to name their company, and what they do is they put the first letter of their first name, last letter of first letter of the second name, combine that, and they make up a name, right? So similar thing happens over here as well. We have num, okay, and we have pi. Okay, now in a very clear vision, what does this num signifies you? If I say num, the first word that came into my mind is numbers. The first word that comes into my mind is numbers. I'm not sure about you, but the first thing is that coming into my mind is the numbers. Okay, we are playing with numbers. Okay, and of course this pi means Python, because all the code of Python has an extension of py, or if you're doing in your what they say notebook, then extension is ipnyb. Okay, so it's a NumPy. That means num stands for numbers, pi stands for Python, right? So that means you are playing with numbers in this Python with the help of Python in this. Okay, and this number section is known as numerical. Okay, and of course this pi stands for your Python. Okay, numerical Python, that means now you are playing with numbers. Now you are playing with numbers. Okay, and let me tell you, when we say numbers, when I say numbers, when we are playing with numbers, which subject, which subject can you relate with numbers? I give you a hint. I give you a hint. It's the most deadliest subject. Nobody likes it. Mathematics, exactly. Okay. So, mathematics is the subject that really haunts me during my school days. But when I've chosen this field, so we have to bear that, right? So, yeah, mathematics. Okay, now the reason why I'm telling you about mathematics is that data science is a field. See, everything has a pros and cons in it, right? So data science is such a field that it is not restricted. It is not restricted by any degree. That's the beautiful advantage of data science. What exactly does that mean? Okay, let me elaborate it. Suppose you want to go for software engineering. Okay, you applied for an IT company. You say that I want a software company. Sorry, I want a job where I can create some software. Right? Company will going to ask you a degree. Right? If in that case, if I say that I am having my English degree, do you think it will going to make sense? Do you think it will going to make sense? Yes or no? I'm applying for a software development role. Okay, I'm going to create software. I'm telling the company that I'm going to create a software, but my degree is in English. I have done masters in English, or you say a bachelor is English, bachelor in English. So, do you think it will going to make any sense? Of course not. It will going to make zero sense or no sense, right? If you're a marketing guy, they will going to ask you about MBA degree. If you say that I am a marketing guy, but I have done bachelor's in computer science, okay, so they will going to give you less preference, right? But data science is the field where, even though if you don't have any computer science degree, first of all, you don't have any BSc degree in computer science, absolutely fine. You don't have BTech degree in IT field, absolutely fine. You don't have any coding background, absolutely fine. That's the beauty of data science, because in data science you should not be a hardcore coder. Okay, one is a hardcore coder. That means you give them a problem, they will going to give you the code. Okay, there are a lot of other domains over here. We have the CP. You must have heard about competitive programming. You might have heard about, right? Competitive programming we have, where we utilize all the data structures knowledge and all that. That is a hardcore programmer. Okay, then we have the intermediate or the middleman programmer, right? They will not going to go deeper in the data structure, but they will going to do their work with the help of coding. Okay, but in data science only asks you to have a knowledge of coding. Okay, it will only going to ask you to have a beginner to intermediate concept of programming language. It will never going to ask you to have high end programming knowledge. Okay, this is the beauty. But the only constraint, okay, over here also it's a constraint. Okay, the only constraint in this data science field is that you should know maths, you should love maths, and you should have enthusiasm to move towards mathematics. Okay, which is very very no I say which is very very challenging for us, because we know that so far we have all the encounters that we have with mathematics, it wasn't that much good, right? It wasn't that much good. We always have hated maths because we never see a real life example of using all those y is equals to mx plus c, what exactly all this cos theta sin theta, we haven't used that, right? But in data science you should know about mathematics. Okay, and the best degree to land into the data science field is either BSc in statistics and mathematics, is the best degree to land up in this part. Okay, computer science is also a good degree, but the best degree in this field is something related with mathematics. Okay, perfect. Now when I say mathematics, that means we are relating that maths with our numpy maths, right? When we say numbers, that means now we are dealing everything with mathematics over here. Okay, so if you're not interested in mathematics, so please, if you are looking forward to this domain, data analysis, machine learning uses a huge amount of statistics. Okay, in machine learning there are 95% theoretical knowledge and only 5% practical knowledge. Why only 5%? Because as I've already told you, in Python everything has been done for you. Okay, Python give you a lot of comfort, so all the libraries has been used. So if you want to do a practical machine learning, it will going to take you only 4 to 5 lines of code, that's it. Just imagine, to do a machine learning to predict something, it will only going to cost you 4 to 5 lines of code, guys, because everything has already been done for you. Okay, now how exactly the model will going to work, that's mathematics. Okay, what exactly is the equation, that's statistics. So the more time you will going to dive and more time you will going to spend on statistics and mathematics, the more better data scientist you will going to become. Always remember this thing. Okay, bit challenging, yes, exactly, it's the most challenging thing that you have to first of all you have to create a bond between you and mathematics. Second of all, in this field of data science, you have to consume a lot more time in reading research papers. Okay, in this domain you have to consume a lot of time to reading research papers, and all the research papers, all the scientific research papers includes a lot of mathematics. Okay, so if you ask me that I want to go to the machine learning, I want to do the machine learning, I want to learn machine learning in 1 month. Okay, so how can I divide my time between statistics and 1 month? I would refer to you, consume your 25 to 28 days. Consume your 25 to 28 days in statistics and the rest days for machine learning. Okay, the more time you will going to give your mathematics and statistics, the more better concept you will going to build up. Is this clear to everyone? Is this clear to everyone? The only motive was to tell you how mathematics plays a very crucial role in this domain. Is this clear? Even though programming also doesn't matter over here, even though programming is not playing that much role, okay, but mathematics and statistics does play a role. Okay, let's come back to the topic. Numerical Python, that means we are playing with mathematics, and to solve all that equations we are using Python to do that. We are tackling those questions, we are tackling those answers with the help of this Python. Okay, but what exactly is this NumPy? See, first of all, NumPy is a library that has came into existence to remove the use or limit the use of Python inbuilt data structure that is known as list. Okay, we have Python data structure. If you remember, we have studied about data structure earlier, right? We have studied about list, we have seen tuple, we have seen dictionary, and we have seen sets. Okay, now if you see over here, we have list, tuple, dictionary, and sets over here, right? Now this NumPy is a total replacement. This NumPy is a total replacement of Python's list. Are you guys getting this? Are you guys getting this? Yes or no? Are you guys getting this? NumPy came into existence to remove all the cons that a Python list possesses. Okay, why only Python list? Why not dictionary? Why not tuple? Why not set? Why only Python list? Many people will going to ask you, right? This is an interview question that has been oftenly asked. If you're going for data analysis interview, for data analysis position and all that, they will going to ask you why NumPy, why NumPy has been created when we have Python list. The reason being is that whenever we deal with the data, okay, from now onwards we are moving into data analysis field. Okay, we are going to perform data analytics and all that, so please listen very carefully. Okay, cool. Now first of all, whenever we get a data, okay, the data most of the time is in a tabular form. Most of the time the data is in a tabular form. What is a tabular form? You must have seen a table. A data in a table looks like this. Okay, this is, let's suppose this is a table. Okay, we have some columns and then we have some rows. This is how a table looks, right? And this is how you must have seen a lot of data that has been stored in this kind of form, tabular data, right? A perfect example is a database, a MySQL database system. If you have seen a database, you will see all the data that has been stored is in a form of a table, right? So what will happen is that we know that the data that is coming is in a form of table. We are not talking about the NoSQL data or the unstructured data currently. Okay, we're going to talk about JSON later. Okay, what happens is that list is meant to be the best, not the best, but most preferable, most priority that has been given to among all the data structure to store the values. The reason being is that first of all, it is not partial as sets. The reason being is that set says that I am only going to contain repeated data. I am going to contain only unique data, not the repeated ones, right? But what does list says? List says no, I am fine. I am okay with that. Give me any kind of data I am going to store. So over here, list won the match with the as compared to sets, right? Then comes tuple. List says that hey, tuple, if you are going to store the data in tuple, then what happens that tuple will not going to allow to update your data. If you're going to store some data into tuple, tuple will not going to allow you to update your data. Tuple is waste then, right? The list says that okay, over here also I won the match. Clear? Now what happens? Now dictionary came into action. Now list says that hey, see, over here dictionary is good, but dictionary, to store something you need to form a key and value pair. To store something you need to follow a key value pair. So that's why list is going to win that match as well. But dictionary says that no, I know my worth, and I'm worthy enough to contain the data. So dictionary has taken some other form known as a JSON data. If you might heard about JSON data, it's a form for dictionary. The data that stores in a JSON, it's a form for dictionary, and all the data that you see in the web, okay, all the data that passes from the interface to the server is in a form for JSON data, guys. Okay, it's in a form for JSON data. That's a dictionary format. Okay, so we have a lot of formats. Okay, so mostly we prefer list, and we have the dictionaries for the JSON data. We're going to talk about that if we get some time, but we are most focusing on list. Right now, the difficulty in list is that list is good, okay, but what happens is that when we store some data in a list, it's perfectly good. The problem arises is that when we store a lot of data, and we know that as we are moving forward, data is increasing. Why data is increasing? I've already discussed that in the first lecture. We have a lot of applications, they are generating some files and so on and so forth. Okay, so as you are moving forward, data is increasing. Are you guys with me? Yes or no? Are you guys with me? Yes or no? Come on. Okay, is this clear? Okay, as we're moving forward, data is increasing, right? So if we want to utilize some data, we have to store the data at somewhere. If we want to utilize the data, we have to use that data. We have to first store it, then only we can use it, right? If I want to drink some water, if I say that okay, I want to drink some water at night, I want to drink some water at morning, right? What happened? I need to first store the water in a water bottle, then only I can have it. Are you guys getting this? Yes or no? So over here we use list for the storing purpose. Over here we use the list to storing the data, but the problem arises is when the data become humongous. And if you are if suppose you are having a list and you're having a humongous data in it, and you're planning to perform some operation because you want to do some analysis, right? You want to do some analysis, otherwise the data is getting absolutely waste, right? So what you do when you perform some analysis, list will going to take a lot of time for processing. That's why we are having numerical Python over here. We have numerical Python, that is NumPy. In NumPy we have NumPy array. We call this as NumPy array. Okay, we call this as NumPy array. Most frequently asked question during interview: what is the difference between Python list and NumPy array? The most simple answer is NumPy array is NumPy array is 50% more faster than the Python list. When we say faster, when we say it is faster, what exactly does this faster means? That it will going to store the data, it not only in a smaller scale but in a larger scale, and at the same time the amount of time that will be required for the processing, it will be much more higher in NumPy array as compared to a Python list. Is this clear to all of you? Yes or no? Is this clear to all of you? Yes or no? Come on. Okay, simple answer is, the question is difference between Python list and NumPy array. Okay, first point, NumPy array is 50% more faster than Python list. First point. Now someone asks you, what does the term faster do you mean? In what sense? Faster means that not only NumPy arrays stores data in a very smaller scale, but in the larger scale. But when we say the term faster, it means the processing speed. The processing speed of the humongous data is way more faster than the Python list. Are you guys getting this? Yes or no? Okay. And second most thing is that it consumes less memory. It is faster, that's why it is consuming less memory as well. If something is faster as well and something is consuming less memory, definitely you should go with that option, right? Are you guys getting this? If I'm having 100 MB and Python list says that I am going to consume 50 MB out of 100 MB, and NumPy array says that I am going to store the same amount of data, but I am going to consume 1 MB in this 100 MB, don't you think I should go with Python? Don't you think I should go with NumPy array? Is it clear to all of you? Yes or no? Come on. Okay, perfect. Now this was a theoretical concept. This was a theoretical concept. Oh, you must say that, okay, sir, you told me that, okay, it's faster and all that, right? But show us the practical. Show us the practical. How can I believe that it is more faster than list? What exactly does that mean? You have told me, okay, it's faster. It will going to do some processing, but tell me an example. Tell me with an example, right? So let's see a practical implementation to justify how NumPy array is much more faster than a Python list. Is it clear to all of you? Is it clear to all of you? Perfect. Let's go. Over here, so first of all, you need to install it and you need to import it. Okay, because NumPy is a library that never comes handy with Python, right? When you install Python, you get a lot of inbuilt module, you get a lot of inbuilt frameworks and all that with the Python, right? But these are some of the frameworks, some of the libraries and packages that has been created by third party. Okay, so what you need to do is you need to go to this website known as PyPy. Google PyPy. What happens that this PyPy, whatsoever you need with respect to Python, either it could be a framework, it could be a package, it could be a module, it could be a library, you will going to find it everything over here in this website that is known as Python package index. Okay, so what we want to do, we want to search for NumPy. So I'm going to write over here NumPy. Okay, over here it's 2022. Yes, so we have to go with this. Now it will going to give you all the documentation. Okay, and over here this is a command to install it. Okay, since we are using Google Colab, so NumPy comes being installed handy. Okay, it comes handy, that means it is already being installed. NumPy is already being installed, pandas is already being installed, scikit-learn, TensorFlow, it's already been installed. But if it's not installed for you, what you can do is just copy this command. If you're working on local, just paste this. Let me write over here for local setup. Local setup means if you're working on any IDE, if you're working on any code editor, okay, like VS Code and all that, editor, or you're working with any IDE such as PyCharm and all that, the command will going to go like in your terminal is pip install NumPy. Okay, if suppose you're using Jupyter Notebook, let me write over here notebooks. Okay, or you must be using Colab, and by any chance if you don't find NumPy being installed, so what you need to do is the command will remain be the same. When you work with notebook, you need to add a exclamation mark to install any library or packages or anything. Okay, is this clear to all of you? Is this clear to all of you? Okay, perfect. And over here you can find out a lot of documentation, and NumPy is open source as well. Okay, we're going to talk about open source in some other bootcamp. Open source is an interesting topic, you should contribute in that. We're going to talk about later. Okay, so just over here you need to install it. Okay, so we are already having this. I'm going to import it. I'm going to import NumPy as NP. What exactly does this piece of code means? What exactly does this piece of code means? As NP means, and this portion is an alias. Okay, that means like suppose we have a person known as Rohit. Right? What we do is we create a shorter version of its name. We say Ro. right? This is Ro is a pet name. Ro is a pet name. Hey Ro, in a very funky way we make out some name, right? And I'm sure everyone has a nickname at their home and at their places, right? Some might be having a lot of stuff, right? But what happens is that if I'm calling Rohit, the person is only same. Okay, if I'm calling Rohit, that I'm referring to that same person. If I'm calling Ro, I am referring to that person, right? What happens is that Ro is much more simpler, much more easier as compared to Rohit, right? Exactly the same way over here is that you can use the NumPy as well, or you can say shorter abbreviation as NP. So instead of using, instead of calling NumPy everywhere like this, we are using, we are writing 5 letters over here. So what I'm going to do, instead of doing that, I'm going to do just only 2 letters. That is just a short form. Okay, you can also use it without this aliases and aliases. Okay, whatsoever you want to call this off. Okay, one more thing that I want to install is time module, and time module comes handy with Python, so you don't need to install this. Okay, so let me run this, not temp file, time module. So why time module? Because time module will going to help us to let know that which array is more faster, whether it's a list or whether it's a NumPy array. Okay, first we're going to start with NumPy. This is for NumPy. Okay, we're going to start with the starting time. I'm going to store the starting time over here. Okay, so I'm going to use the time module, time.time. Time.time, what it will going to do, it will going to store the current time. It will going to store the current time into this variable starting time. Then we're going to do some process, and then I'm going to store my finish time or the stop time whatsoever. Over here it will be time.time. Okay, this is your starting time. Over here some process will going to happen, and then we are having a finishing time. And then what we're going to do, we're going to print this up. We're going to say finish time minus start time. It will going to give me the total time that has been taken to do this process. Are you guys getting this? Are you guys getting this? Yes or no? Are you guys getting this? Yes or no? Come on. Okay, perfect. So what I will do, I am going to create a random numbers. I'm going to create a huge random numbers now. Okay, so I'm going to use NumPy only to create a huge random numbers. I'm going to say numbers. Okay, I'm going to use a function known as random. Sorry, not I'm going to use a package known as random, and I'm going to use a function known as rand. Okay, over here I'm going to say, okay, what exactly does this mean is, this random is a package. Okay, in this package we are having a function known as rand, and I'm giving a number. It means what I'm telling is, when I'm telling this NumPy to create some random numbers, between this rand function will going to generate some random numbers between 0 and 1. Okay, between 0 and 1 it will going to create random numbers. And how many random numbers do you want to be get created? I'm giving this number that I want these many random numbers to be generated, right? If I say range is over here as 0 and 1, right? I'm saying create 10 random numbers. So what will going to be the output? It may be 0.123, it might be 0.456 and all that. How many times? 10 times, right? So over here I'm telling create some random numbers between 0 and 1, and how many random numbers? This many random numbers. Getting this? Understanding what exactly this piece of code means? Yes or no? Okay. You can also use random module for this process as well. Okay, no hard and fast rule in this. So let's generate this, and we're going to consume a lot of memory. Let me open the memory disk on the right hand side and just see the system RAM. So let's run this. NP is not defined, sorry, as NP. Perfect. Now it will going to create these many random numbers. Now how many random numbers will be generated? Can you tell me what exactly is the value of this number in million, thousand, or so on and so forth? Can you tell me? Anyone? You can see the RAM consumption. RAM consumption has gone higher. Okay, perfect. Anyone? Okay, now let me show you how exactly numbers are being looking. So see, these are all the numbers that has been created. Over here you can see dot dot dot. because they are not giving us all the numbers, right? Because if it will going to give, it will be a huge page. Okay, so we are having these numbers, and if you suspect that it will not going to be all the numbers that contains in the list is not these many, so I'm going to use a len function. Okay, it will going to give us exactly the same number that has been generated over here, right? What we're going to do is we're going to calculate the mean. This is the mean for the numpy. Okay, and I'm going to copy the same part and I'm going to put it over here and say this is your Python list, and this is a mean for Python list. Okay, I'm going to create a mean. What exactly is mean? What exactly is mean? Anyone? Average, mean. What is the formula of mean? Anyone? Sum of all the numbers divided by the length of all the elements or number of all the elements. Yes or no? Yes or no? That's what is mean. Getting this? Come on, come on, come on. Fast. Okay, so we are going to calculate the mean. So I'm going to use a function np.mean, and over here I'm going to pass the numbers. Okay, I'm going to pass the numbers. Okay, and this is a mean list, so I'm going to write over here sum of all the numbers. So we have the sum function. I'm going to write over here numbers. Okay, divided by the length. That means how many items you are having. This is a formula of mean or finding an average. Okay, so now I'm going to run this cell. Let's find out that how much time this numpy will going to take. It will going to give us the time in a seconds, and let's see how much time this list will going to take. Okay, let's see this. Let's run. Perfect. We have not even consumed a second as well. We have not even consumed a second as well. Can you see? For processing these many numbers, we haven't taken a single second. It is approximately a second, but not definite second, right? It is 0.8 second. That is 8 millisecond, you can say. Let's go with list. And this will be a lengthiest process. It will going to take a lot of minutes to do that. Okay, the motive here is to tell you that when you move on to the data analysis, okay, or in the machine learning part or deep learning part, you get a humongous data. Okay, and not only that, you get humongous data, you want humongous data, because more the data will be, okay, more accurate your model will be, because you will be having different scenarios to train your model. Okay, more the scenarios, more the experience, more better a person become. Right? If you don't have any experience, you will oftenly going to make some mistake. Okay, if I am having some experience, I am most rarely going to make a mistake. Right? It will be a very like a once in a blue moon I'm going to make a mistake, but for you you will going to make mistakes on and on and on if you don't have experience. Right? So if we get more data, that's better for us. Okay, but when we are getting more data and we are trying to process out the same thing in our system, over here the main thing is about the computation power. Right? Like suppose you are performing some higher computation. Okay, but for that you need a computer, you need a system to do that. Right? If suppose I have purchased a system of i7, let's suppose this is not i7, let's say M1 chip. Okay, I am performing some computation for M1 chip, and I am performing the operation that cannot be done on M1 chip. It needs some higher configuration. So does that mean that I should immediately go and purchase another computer for that? Do you think it does it makes any logic? Does it makes any sense? Absolutely not. Yes or no? Absolutely not. Right? So what we do is we have different techniques that how we can try to process out these kind of data in a very minimal configuration. Okay, if you are using a list is good when you are dealing with a very shorter period of data and shorter data, right? But when you are dealing with a humongous data, you need to go with some agile solution where the less time will be taken, less computation power will be taken, and less storage will be taken. Okay, so these are the three reasons why we are shifting towards numpy array. Okay, and this is not mandatory that you always need to use numpy array. No, if you're using numpy array for like 10 data, 20 data, you will going to see no difference in a list or in numpy array. Okay, so they both are used in a different scale. Okay, so if you're making some softwares, you say that I'm making a software and let's try numpy array. It will not going to help you out. It will never going to help you out with that. Okay, you have to stick with Python list only. That will be the more better option for you. Okay, let's see whether it's still going on. Yep, it is still going on. See, the processing is still going on. And over here we have consumed only 1 second in NumPy. Is it clear? Is it clear to all of you why when we say NumPy is faster than list, what exactly does that mean? Is it clear? Is this clear to everyone? Yes or no? Okay, perfect. And NumPy pandas is a very vast topic. Okay, it's a very vast topic. Unless until you know about it, you cannot go forward, right? I think it's been done. Is it? Finally, it's done. It has taken 188 seconds. Let's see who will going to convert this 188 second into minutes and tell me how many minutes did it take. Come on. I want to hear first. How many minutes is it? 188 second is equal to how many minutes? Come on. Let's see. Let's see who will be the first for the answer. Very simple, guys. 3 minutes, approximately 3 minutes. Approximately 3.3 is more precise. Okay. How come it will be 2? It cannot be 2, guys. It cannot be 2, right? Perfect. Approximately it's a 3 minute and precisely it's 3.3 or 3.8, whatsoever you want to call it. Now, if someone asks you, you're doing the same process in 1 second as well, and that process, one person is saying that I am going to do the process in 1 second, other person is saying that I am going to take 3 minutes 8 seconds. Which among them do you going to you want to go with? Do you want to go with NumPy or do you want to go with list? Come on. Anyone with list or anyone with NumPy? Come on, come on, come on. I'm going to go with NumPy. I'm going to go with NumPy for sure. NumPy, exactly, right? So this was a real life example to demonstrate to you how and what exactly does it mean when we say NumPy is faster than Python list. Okay. So obviously we cannot cover all the topic about NumPy over here, right? We have to skip a lot of things, but you should know how exactly we create an array in a NumPy. Okay, now suppose if you want to create a list, right? If you see over here, if you want to create a list, let's suppose this is your list. Let me write over listy. If this is a list, the basic syntax of creating a list is this bracket and all the data and datas inside this. This is how you will going to create a list. Okay, this is one method, or you can create a list, or you can create an empty list as well. This is known as an empty list. Listy1 is known as the empty list. What is empty list? A list that is empty, that doesn't have any element. Okay, this is one way that you can create an empty list, and this is another way how you can create an empty list by using the typecasting method, a list function. This is also a list. Okay, so these are the methods how you can create a list, right? Now if you want to switch to a NumPy array, how you can create a NumPy array, the basic syntax of NumPy array is, we also call this as a ND array. Okay, NumPy array. You use NP, that is your NumPy. Okay, from this NP you say I want to use array, I want to use the function as array over here, and then it will be this this square bracket, and over here you can put your data and datas. Okay, now what happened is that this one more speciality of NumPy, that not only you can store two-dimensional data or one-dimensional data, but you can store multi-dimensional data over here. You can store multi-dimensional data over here, guys. Okay, not only a single dimension or two dimension, but you can store three-dimensional data, four-dimensional data, and so on and so forth. Now people will be getting confused. What exactly does you mean about dimensional data? How exactly one dimensional, two dimensional, three dimensional looks, and what exactly does this mean, right? So what exactly means of a dimension is the axis. How many axes you are preferring. Okay, if let me show you an example. Okay, now when we say axis, suppose this is one axis, this is one axis. Okay, over here this is two axis, and this is three axis. This is two axis, this is three axis, right? So we call this as a one dimensional because it has only one axis. Okay, we call this as two dimensional because it has two axes, that is a x axis and a y axis. Okay, we call this as a three dimensional because it has a x axis, it has y axis, and it has a z axis or z axis. Okay, now you can see how we are moving towards mathematics, right? So you need to understand what is this three axis and all that, right? So this is an example about the dimensional of data. So what happened is that currently most of the time what happened is I've already told you the data are coming from tabular form. Datas are coming from a tabular form, right? If you see if you see this is a table. If I ask you what dimension do you think is it? What dimension do you think is it? Come on. What dimension? Is it 1 dimension, 2 dimension, 3 dimension, 4 dimension? What dimension is it? Come on. Tell me. What is the dimension of a table? What is a dimension of a table? 2D, exactly. It's a two-dimensional, right? How exactly it's a two-dimensional? Because we have one axis, and we have another axis. We have two axes over here, right? Sometimes this is also, suppose this is your two-dimension. And now how about now? What is the dimension? What is the dimension of this data? What is the dimension of this data? Come on. 3 dimension, exactly. You guys are getting this. Awesome. This is a 3 dimension, right? So what happened is that in a current scenario, most of the time data comes from 2D format. That is a tabular format, right? So we have to deal with that. But we have a lot of assumptions, and we are now getting data in different dimensional as well, right? So in future we are not only limiting with 2D or 1D or 2D, but we are moving towards the 4 dimension, 10 dimension, 8 dimension, and so on and so forth, right? So what happened is that if that's the case, that means that for each dimension we need to create some other libraries, right? So what NumPy company has done is, NumPy company has focused on all the dimension. They say is that it doesn't matter if the data is in any dimension, we are here to help you out. Okay, so that's the biggest problem that NumPy solves. Okay, now to create the dimension, okay, so suppose this is one data. This is a syntax for you. Okay, so let me create ASD is equals to NP dot array. Okay, over here I'm going to write 1 2 3 4 and 5. Okay, so if you see over here, this 1 2 3 4 5, it's just a one axis. It's just a single axis, guys. Okay, so how can I verify that how many dimension is it? So let me tell you, ASD is over here. Okay, we have a attribute known as ndim. Okay, we have an attribute as ndim. This n means number of dimension, where n stands for anything. Okay, where n stands for anything. It could be a 3 dimension, 4 dimension, 5 dimension. Okay, so let's run this up, and it says 1. That means this is a 1 dimension because we have only one axis. Over here we have only one axis, right? If you want to go with 2 axes, if you want to create 2 axes or 2 dimension, what you need to do, this is 1 dimension, right? Let me copy this and let me do this. Oh, where is it? This is your array, and let me do this once more. So if you see over here, now it has become 2 dimension. The one axis is over here, horizontal, other is vertical, right? So now if you're going to check this, you will going to find out. Let me print this ASD over here, so it will be very easy for you to take the reference. See, this is one axis and this is another axis. Okay, now if you see the dimension, now it says it's a 2 dimension, and most of the time you will going to get the data in 2 dimension only, where you will be getting rows. These are the rows, and you will be getting the columns. This is column 1, column 2, 3, 4, 5 and 6. Is it clear to all of you? Is this clear to all of you? ASD is the name of variable. Okay, I can take anything over here. See, ASD is the name of a variable. Okay, it is nothing, it doesn't mean anything, it's just a name of a variable. Okay, perfect. Is this clear to all of you? Guys? Yes or no? Okay, so what happens is that in NumPy you can deal with multi-dimensional data, whereas in list you cannot. This is also a second example. This is also a second you can say second differentiation between a Python list and a NumPy array. Okay, in NumPy you can deal with multi-dimensional data, whereas only in list you can only deal with a limited dimensional data. Okay, and how you have to create a NumPy array, we have already seen the syntax. Okay, and there are various operations similarly. Okay, how you can add it, you can update the same way we do in list. we how you can refer, how you can update each value using the slicing and indexing. Exactly the same concept of list has been followed up over here, because if someone is moving from list to numpy array, so we don't want them to get confused, we don't want them to confuse, right? Over there the concept was this, and over here this the concept is absolutely different. So the company has made sure that all the concept of list has been followed up over here. If you know list, if you know the working of list, if you know how to update a list, add a list, delete a list, everything will remain be the same in the numpy array. Is this clear? It will going to make very easy for you to understand about the numpy array. Okay, and there are a lot of attributes that I want you guys to explore. Okay, the best reference that I can give you is go to W3S school. Okay, W3S school, refer to that, and you will going to find everything on numpy. Okay, because we cannot cover each and everything in a single session. Okay, so some hard works you guys also need to do. Okay, is this clear to everyone? Is this clear to everyone? Yes or no? Okay, will you gonna do that? Come on, will you gonna do that? Will you gonna consume like 5 minutes of your time and search for how exactly is the working of numpy? Will you gonna do that? Yes or no? Okay, so numpy is all about list. Partially it's all about list, but is way more beyond the concept of list. Okay, it is way more beyond the concept of list. Okay, perfect. And let me show you the W3S school as well. Otherwise, people will going to forget about the name. What you need to do, you need to write over here numpy and W3S school. Okay, very simple language, simple language has been given to you. Okay, you can see indexing, slicing, everything will remain with the same. Data type is over here as well. Copy and view, you need to understand what is copy and view. There are two functions. Okay, they work in a similar way, but they have a different operation. Okay, then shape, what is the shape means that how many rows and column, right? When we create a matrix, you must have heard about a matrix. This is a matrix, right? In this matrix, when we say what exactly is the matrix, this is an n cross n matrix, this is a 3 cross 3 matrix, it could be a 4 cross 4 matrix. How you will going to find out the matrix? That means number of rows into number of columns. Okay, so you can use this shape. If you want to reshape, you want to rebuild your matrix, okay, from changing from one shape to another, you can refer to this reshape. Okay, so if you want to iterate the items from a matrix, okay, or item from a numpy array, you can see this as well. Okay, so everything has been given in a very greater form, you can understand. And from here, this is your statistical part. This is your statistical part. You will be it will be very confusing for you at the first glance, but this is required to move on with further knowledge. Okay, is this clear? Is this clear to everyone? Okay, is this clear to everyone? Yes or no? Perfect. So let's end our session over here itself. Okay, the motive about that this session was to give you a glance about what is numpy, how exactly numpy is different, because these are the most asked question. These are the most asked question, and many times what happen is that students or all the candidates says that numpy is faster than list. That's it. But the main thing is why it is faster. Why it is faster, and how, if I say to demonstrate me how is it faster, how can you tell me? So main motive is to tell you all the counter questions, so you can refer to that in your interview. Okay, perfect. So let's end up this session over here. Tomorrow we're going to understand about pandas and how pandas can benefit us with the help of this numpy. Is this clear to everyone? Is this clear to everyone? Yes or no? Perfect. So let me give you the attendance link, and thank you so much. For the first time I'm seeing over here nobody's asking for attendance. Okay, so thank you so much for that. Awesome. Okay, so here you go with your attendance, and make sure you need to have 100% attendance. If you have forgotten about yesterday's class where we have created a simple if and else stuff, if you want to go, if you want to check whether you are going to get attendance or not, so please fill your attendance form. Okay, so thank you so much for joining in, guys. Have a great time, enjoy yourself, and please, it's a request, do give a sight and glance to this content, that is W3S school about NumPy, because it will going to help you out a lot, and try to focus on different technologies as well. Don't limit yourself, because it's not a time for you guys to limit yourself to one thing. Okay, you have a lot of time in the upcoming ways, like after you will be after 10 years, 14 years, 5 years, there's a lot of time for comfort zone. Okay, there's a lot of time for your comfort, to enjoy your comfort and all that, but this is the very high time for you guys to do something unique. So please don't let anyone to push you down. Okay, and don't let yourself to push you down. Okay, do something unique, make your interest, and please go for it. Okay, so thank you so much for joining in. Have a great time, enjoy yourself. Let's meet tomorrow, and we're going to learn something new, definitely. Okay, thank you so much. My contact ID has been given on the description, you can refer to that. You can connect me with you can connect me on LinkedIn. Okay, so thank you so much, guys. Thank you, bye, see you all.